This lesson will be on proving either lines parallel or angles congruent once we have parallel lines. What I want to focus on in this is not only constructing the proofs, but also recognizing that these theorems that I'm going to use, their converses are also true. So we can use either direction. We can use the original theorem or the converse. So this first proof, it has all these angles listed. Sometimes this is called a hashtag proof or maybe a tic-tac-toe proof. What I like to do on this is to focus on when these lines are parallel and the transversals are parallel, what is my ultimate goal by circling it? I'm going to go from 7 over to 15 to prove those angles are congruent if the original lines are parallel. And the way I have to do it, there's no transversal connecting the two of them. So I have to go either up and over to get there. So I go up to this set of angles first and then over to this set of angles, or I go over here to these angles and then up. There's actually several ways to do this proof. As you'll find with all of these, there's usually several ways to do it. I'm going to focus on going up this transversal and then over on this transversal. So the one I'm going to focus on is I'm going to go for this in-between angle of angle 9 to get me there. So the first statement is the given, M is parallel to N and A is parallel to B. That's given to me. The second step is I'm going to go up this transversal, and 7 and 9 are connected by that transversal, and they're congruent because if we start with parallel lines, that's my hypothesis, I know that alternate interior angles are congruent. So alternate interior angles are congruent. So that's a conclusion I can use. Now, if I use angle 9 and use this transversal to go over to 15, I know that these two are corresponding angles following this transversal. So I can state that angle 9 is congruent to angle 15, and that's by these two being parallel with this transversal, so corresponding angles are congruent. Now I've got my way over to this one. I can now look at this and see if angle 7 is congruent to angle 9 and angle 9 is congruent to angle 15, then by transitive I can state that angle 7 is congruent to angle 15. So angle 7 congruent to angle 15, and that's by transitive. And I've proven my statement correct. All right, let's try the next one. This is proving that angles are congruent. This one I want to prove lines are parallel. So I'm going to use the converse of my theorems and postulate in this. So I'm going to start with stating my given. Angle 1 is congruent to angle 3, and angle 2 congruent to angle 4. Now just thinking my way through this proof to kind of set a goal for where I'm going to go ahead and mark this. 2 is congruent, angle 1 is congruent to angle 3. And I can look at this and say, because I've got these two being vertical angles, I can say that they're congruent. So if 1 is congruent to angle 3 and 2 is congruent to angle 4, notice that these guys are going to be alternate exterior angles. If I can use my transitive property, I'll be able to transfer those congruencies to these two, and I'll have that angles are congruent leading to parallel lines. So now let's go ahead and state that angle 3 is congruent to angle 4. And that's because these are vertical angles. So vertical angles are congruent. Now, if 3 is congruent to 4 and 2 is congruent to 4, then angle 2 is congruent to angle 3. That's by transitive. Okay, now I've got 2 congruent to angle 3. Well, 1's congruent to angle 3 also. So if 2's congruent to angle 3 and 1's congruent to angle 3, both 1 and 2 are congruent to the same angle. So angle 1 is going to be congruent to angle 2, and that's by transitive again. So we just used transitive twice. So 2 different sets of angles. Now these two being congruent to each other, those are alternate exterior angles, so that means that the lines are parallel if those angles are congruent. Now what I started with here is in this statement, the alternate exterior angles congruent. That led to parallel. Now what I want to point out is, since the converse works, if you're not sure which to start with to produce the other, it's always start with the hypothesis. I had the angles, so I started with those, and I concluded the lines parallel. But if you're not sure, you can always just make this into a double direction arrow, because it's a biconditional, since the converse works. And I could do that here too. I could make these both directions if I'm just not sure which is the hypothesis, because both the original and the converse are true. All right, let's do this last one now. Let's state our given. We've got that K is parallel to L, and we have that L is parallel to Q. That's given. The second step here, now notice what I'm trying to prove is that if these two are parallel and these two are parallel, trying to prove that if 2 lines are parallel to the same line, they're parallel to each other. Now, I'm going to do that. I could put in extra angles and use congruencies. I'm going to use the fact that these are same side interior angles. So if I've got angle 4 and angle 3, angle 4 is supplementary. I'm going to abbreviate that SPPL, is supplementary to angle 3. Okay? And the reason for that is if I start with parallel, I know that same side interior angles are supplementary, abbreviated SPPL. Now, I could use the same reason to say that for these two. Angle 1 and angle 2 are supplementary. So angle 1 supplementary to angle 2, and the reason for that is parallel leads to same side interior angles supplementary. Now, looking back up here, I also know that these two are vertical angles. So I'm going to state that angle 2 is congruent to angle 3. And that's because vertical angles are congruent. Now what I've got is that 4 supplementary to 3, 1 supplementary to 2, and these two angles are congruent. What I have is another theorem that we've already proven to be true, is that if 2 angles, 4 and 1, are supplementary to congruent angles, they themselves are congruent. So I'm going to state that here, that angle 4 and angle 1 are congruent. Okay, 4 and 1, and that's because we have supplements of congruent angles are congruent. That's a theorem that we can use, okay? The given is supplements of congruent angles. What we have then is the conclusion that they're congruent. Now, if you look at 1 and 4, I'm just going to draw it here because we have to ignore the middle parallel line. These two are alternate interior angles for the outside 2 ones. So I can now state that K is parallel to Q, and that's because if we've got alternate interior angles congruent, the lines are parallel. Okay, and I'm going to do a double arrow just to make sure I know that the converse is true. So we use the original theorems and postulates and their converses in this to not only prove that angles are congruent, but we also used them to prove that lines are parallel using the converse.